Hello, we discuss here Debye-Hückel limiting law. We already discussed that ionic strength of solution and problems based on some small problems based on that ionic strength of solution. Then now we discuss Debye-Hückel limiting law, which gives equation that known as Debye-Hückel rule or Debye-Hückel equation, and that equation gives relation between ionic strength of solution and ionic activity coefficient, that is gamma plus minus. This solution, Debye-Hückel limiting law give relation between gamma plus minus, that is ionic activity coefficient of solution, and ionic activity mu. That relation between these two quantity is given by Debye-Hückel limiting law. We discuss here law for strong electrolytes that are we know that as per definition of strong electrolytes, those electrolytes which dissociates completely in solution, that are known as strong electrolytes. Therefore, that electrolytes completely ionized in dilute solutions. Solution must be dilute, then only that strong electrolytes completely dissociate in solution, dilute solutions. That Debye-Hückel law shows that because of electrostatic forces of attraction between the ions in solution, each positive ion is surrounded by negative ion, and each negative ion also surrounded by positive ions in solution. Then dilution of such solutions involves an additional work required against this electrostatic forces of attraction, in addition to the free energy of dilution for an ideal solution. On dilution, these ions goes away from each other, and therefore some additional energy is required so as to break that electrostatic forces of attraction between the oppositely charged ions. This additional free energy change for dilute solutions is determined only by decrease in ionic concentration. Decrease in ionic concentration. And the difference between actual and ideal free energy change, ideal and actual calculated free energy change during dilution, that difference between these quantities gives a measure of activity coefficient of the ions in solution. Based on all these assumptions, Debye-Hückel obtained the relation between mean ionic activity coefficient gamma plus minus and ionic strength mu for an electrolytes, and that equation is given as, that relation is given as, log of gamma plus minus is equal to minus a into z plus into z minus into under root mu. Log of gamma plus minus is equal to minus a into z plus into z minus into under root mu plus c into mu, where a is constant whose value is 0.509 at 298 Kelvin temperature, and Z plus and Z minus are the numerical valency of cation and anion in the solution. And for very dilute solutions, the quantity C into mu is very small and can be neglected. Therefore, above equation becomes log of gamma plus minus is equal to minus A into z plus into z minus into under root mu. This is important equation for numerical problems, for solving problems, and this equation is known as Debye-Foucault limiting equation or Debye-Foucault limiting law or only limiting law equation. That is log of gamma plus minus is equal to minus a into z plus into z minus into under root mu. This equation indicate that with increase in ionic strength, that is mu, increase in ionic strength mu, the activity should decreases, and this um, decrease is more considerable for higher valence ions, that is solution containing higher valence ions. Then using this equation we can calculate mean ionic activity coefficient for any solution. That is, first by using ionic strength equation. For example, here we discuss a problem that is calculate the mean ionic activity coefficient, that is gamma plus minus, for 0.02 molar sodium sulfate solution Na2SO4. Then from the equation of uh, ionic strength, first calculate mu, that is ionic strength is first calculated, and from dissociation of sodium sulfate ionic strength calculated, and then from ionic strength we calculate log of gamma plus minus by using Debye-Foucault limiting law. Try to solve some examples on the basis of this Debye-Foucault limiting law. Okay, thank you. Then uh, for next lecture we discuss classification of electrochemical cells. Thank you.